if you want to, there's some tools out there that can do that. If you contact me, I can send you how to do that. But so you can create a raster that you can use. The problem with that is that there are zones that they don't suggest you do an interpolation. They have some polygons built into the model that say, okay, we shouldn't try to interpolate in these areas because we actually haven't modeled them. This is usually up in some of the estuaries and whatnot. So the only other way to do it is, you're right, you can only do point-by-point conversion, but you can also do a batch conversion. So you could make, you could use a raster or a grid and get the values, the centroids for those, and run them all through the VData model to produce what you're looking for. So you can kind of do that spatially instead of just point-by-point. So there's kind of two ways to do it.
Okay. Let's see. I'm nearing the end. Okay, one comment question. Thank you for the good presentation, discussion of sea level rise impacts. I like the coastal flood frequency viewer. This seems valuable for inundation from tidal events. What do you recommend for visualizing storm surge and related flooding events, such as changes to the 100-year or 50-year flood zones?
Yeah, we get a lot of the questions about that. We have elected not to include storm surge into this. You could use this viewer for if looking at what potentially would be flooded from a 6-foot, above mean high water surge. We have been trying to, and there's various partners that would, pull in the base flood elevations and the digital flood insurance rate map data from FEMA, for instance, into another viewer. This is what our folks in Rutgers